Opties! Today we are factoring polynomials. This will include some quadratics, some cubics, and some quartics with several different methods, and we will also be solving several of these. So let's go ahead and take a look. First, we are factoring and solving difference of squares polynomials. Looking at our pattern here, we have a squared minus b squared equals the quantity of a plus b times the quantity of a minus b. And this is the pattern for factoring. You always use this whenever you have a binomial where it's a difference, so you've got subtraction, and the first and last term are both perfect squares. Looking at number one, we have a difference of squares because we have subtraction, and 144 is a perfect square along with x squared, and 16 is also a perfect square. So if we want to figure out what a and b are, we would just take the square root of the first term, just keeping the positive for each of these. So this would be 12x, and then the square root of our last term, and here are our a and b terms. So to factor this, we have 12x plus 4 times the quantity of 12x minus 4, and that still equals 0. To solve, we set each factor equal to 0. 12x plus 4 equals 0, and 12x minus 4 equals 0. So we can subtract 4 from both sides. 12x equals negative 4. Dividing both sides by 12, we get that x is equal to negative 1/3 for our first 0, or our first solution or root. Secondly, we'll add 4 to both sides. Now 12x equals positive 4. Divide both sides by 12, and x is equal to positive 1/3. We have two solutions. We don't have any factors that have any exponent other than 1, so both of these have a multiplicity of 1. And it makes sense for us to have two zeros because our degree is 2. So we should either have two separate zeros or one zero with a multiplicity of 2. Next, we have a quartic difference of squares. We know this counts as a difference of squares because x to the 4th is a perfect square. The square root of that is just x squared. So let's find a and b. So a should be 3x squared, and the square root of our last term is 5, which is our b. So to factor, we have 3x squared plus 5 times 3x squared minus 5 equals 0. And let's solve, setting each factor equal to 0. Now, don't forget, after we subtract 5 here, we want to isolate our x squared, so we'll divide by 3 first. But now that we have x squared isolated, or by itself, we have to get x all the way by itself by taking the square root of both sides. And don't forget, the square root of a negative number would make an I come outside the square root, because the value of I is the square root of negative 1. I is the square root of negative 1. So here's our final solution for our root, and it's better to call this a root than a 0 because it is imaginary. It doesn't actually cross the x-axis. Working on our second one, notice we're going to have a positive 5, so we won't have an I here. Taking the square root of both sides, and x, oh, by the way, you may have noticed I just remembered I did forget the plus or minus over here. Anytime you take square root, it's plus or minus. So this one is also plus or minus, but we just have 5/3 underneath the radical. There's no I there. So here are our final 4 roots, and I'll just write them separately. I square root of 5/3, negative I square root of 5/3, square root of 5/3, and negative square root of 5/3. 4 roots matches our degree here. They're all multiplicity of 1. Next, we have sum of squares. There's a really great Khan Academy video describing why this pattern works. Let's just go ahead and apply it though. So very similar to the difference of squares, but we have a sum instead, and we have bi instead of just b. So finding our first term here, we'll take the square root of our first term for a, square root of our second term or last term for our b. And now we just put it into our pattern. 6x plus 9i, 6x minus 9i. And again, we know it's the one with the i's because of this plus, the sum of squares. And that still equals 0. Set each factor equal to 0. So let's subtract 9i from both sides. 6x is negative 9i. Divide both sides by 6. And x is equal to negative 3/2 I. And we're adding 9i to both sides, dividing by 6. I'll just do this a little quicker. It's very similar, you know, solving in the math, and we get a positive 3/2 I. So here are our two zeros there. And again, it's probably better to call them roots to encompass both of these because we know the imaginary doesn't actually cross that x-axis. It's just an imaginary or complex root. Number 4, we have another sum because of our plus of squares, because 49 is a perfect square, so is 36, and so is x to the 4th. Just because it's not x squared doesn't mean it won't work, as long as it's a perfect square. And sometimes you even have variables for your second piece too. So square root of 49x to the 4th is equal to 7x squared. And the square root of 36 is 6. Again, we're just taking the positive of these. So to factor, we only want to factor this one, is 7x squared plus 6i times 7x squared minus 6i equals 0. Okay, Opties, we have looked at sum and difference of squares. Now we're going to look at difference and sum of cubes. And it's not going to end up as two binomials, it's going to end up as a binomial times a trinomial. So 2 terms times 3 terms. And the pattern in terms is actually the same. The only thing that changes between a sum of cubes rather than a difference of cubes is the signs. But there is a little acronym that helps us remember how the signs operate. It's same, opposite, always, positive. It's SOAP. Same, opposite, always, positive. Same, opposite, always, positive. That tune is from when I went to camp way back in the day, and there was a song called Calamine, Calamine, Calamine lotion. Calamine, Calamine, Calamine lotion. Oh, no, 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 not the lotion. Same, opposite, always, positive. Same, opposite, always, positive. So not lotion, but soap. So let's go ahead and dive in and see this in action. And don't forget to wash your hands with soap. So here are the rules for difference of cubes and sum of cubes. As you can see, they start with AB for the binomial, and then they have a squared, AB, and b squared for the trinomial. The same terms, just different signs. So for the difference of cubes, your given cubic is a minus, right? It's different. So the sign on the first factor, which is your binomial, is the same sign. It's also a minus. Then it's the opposite sign, which of course is a plus compared to the minus. And then the third sign is positive because it's always positive. So looking over here for sum of cubes, the same SOAP deal. You've got this plus, so it's the same sign, it's a plus. Then it's the opposite sign, which is a minus, then it's the always positive. Same opposite, always positive. So number 5, let's factor and solve this. Instead of finding our a and b with the square root, we'll take the cubed root of each of these. So 8x cubed, the cubed root of that is 2x, which is our a. And the cubed root of 1, remember we're not taking the sign with us. The sign tells us what type of pattern we're using for factoring. That's 1, which is our b. So we're going to do 2x, 1. So that's just the a and b. Then we have a squared. So 2x, the whole thing squared. Then we have a times b, so 2x times 1, and then we finish with b squared, which is 1 squared. And I'll put that in parentheses as well, even though it doesn't really change much for us, but it's just a good reminder. Now let's figure out the signs that go here. It's the same sign, so it's minus, then it's opposite, so it's positive, then it's always positive. So 2x minus 1, 2x squared, the quantity of 2x squared is 4x squared. Then we've got 2x times 1, which is 2x, and then we've got 1 squared, which is 1. So here is our factored form. We do need to solve this. So 2x minus 1 equals 0, and then 4x squared plus 2x plus 1 equals 0. We add 1 to both sides and divide by 2, we get 1/2. And this is a quadratic. We could check to see if there are factors of 4 that add to 2, which there are not. So we'll have to use the quadratic formula to finish out solving this. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There's just a reminder of a way to remember that. So negative 2 plus or minus 2 squared is 4. 4 minus 4 other 4s is negative 3 times 4. So that's going to be negative 12. And then over 8. So x is going to be equal to negative 1/4, if we're taking that 2 over the 8, plus or minus. We've got an I out front to take care of our negative underneath our square root. 12, if we do a little factor tree, could be 2 and 6 is 2 and 3. So we've got a pair here. A 2 comes out, square root of 3 over 8. So finally, negative 1/4 plus or minus the 2 over the 8's another 1/4, square roots of 3. All right, so let's write out our solutions over here, or our roots. X is 1/2, but it's also our negative 1/4 plus or minus, so that's 2 of those here, a positive and then a negative of this, 1/4 square roots of 3. And this can also be written, since the 1/4s match up, we could do negative 1 plus or minus the square root of 3 over 4. And that looks a little bit better, so you might see it that way as well. Let's factor just one more difference of cubes. So the cubed root of 64x cubed is 4x. No, that's our a. And the cubed root of 343 is 7. So 4x, then we've got a 7. We've got our a squared, which is 4x squared, all that squared, so it's 16x squared, plus multiplying these together, so our 28x, and then our b squared, which is 49. And let's do our signs. So same, opposite, always positive. So there is our factored form. Now we have sum of cubes. Very similar, again, just changing those signs. So let's find our a and b for number 7. The cubed root of 27x cubed is 3x, and the cubed root of 125 is 5. So 3x and a 5. 3x quantity, the quantity of 3x squared is a 9x squared. Multiply these together, you get 15x. Last term is the b squared, which is 25. So it's a plus, so it's the same. Opposite, always positive. And let's solve. 3x minus 5 is 0. Add 5 to both sides and divide by 3, you get 5/3. And let's look at this one. 9x squared minus 15x plus 25 equals 0. With this second factor, if you graph it, you will see that it does not cross the x-axis, so it has imaginary solutions, so you would need to use the quadratic formula. I'm going to write that out and show you the work, but I won't show it in the video. You can pause it and look through it if needed. All right, there's the quadratic formula finding these two solutions, 5 plus or minus 5i squared to 3 divided by 6, which are the two solutions from this second factor. So 3 total solutions there. Let's just factor this one. We've got x and the cubed root of 216 is 6. So we got x and a 6. We've got x squared, 6x, and 36. Now let's look at the signs. We've got same, opposite, always positive. All right, Opties, now let's remind ourselves of how to solve trinomials. We've got some quadratic trinomials and some quartic trinomials, which are very, very closely related to how you factor the quadratics. You just put an x squared instead of an x for each factor. So looking at the difference between the quadratic trinomials and quartic trinomials, we just see that we've got some different exponents. So we've got x squared and then an x term and then a constant term. Then we've got x to the 4th, an x squared term, then a constant term. And we've got x plus or minus something with a space in front, which could be some sort of number. Same here, space in front, but instead of x plus or minus for each factor, it's x squared plus or minus. And both of these do factor into two binomials. Number 9, a equals 1. This is a simple finding factors of c that add to b. So factors of 30 that add to negative 11, that's going to be negative 5 and negative 6. So to factor x minus 5 and x minus 6, that equals 0. So x will equal positive 5 and positive 6 if you set both of those factors equal to 0. Number 10, we are factoring where a does not equal 1 since there is no GCF because 15 is not even. So we're going to use grouping or our box, which is really the same thing. So factors of 2 times 18. So factors of 2 times 18 that add to 15. And that's going to be a 36. So what are those numbers? That's going to be a 12 and a 3. So we have to make our box or our grouping. I'll do the box. The top left is your ax squared term. Bottom right is your constant term, and then you substitute with these numbers because they replace your bx term because 12x plus 3x equals 15x. And I'll go ahead and do grouping over here just for the sake of it. These two terms mean this. And that's because they have just replaced this 15x. All right, so we're finding the GCF of all the rows and columns. So we've got a 2x here. We've got a 3 here. It's going to be positive. We've got an x here. And we've got a 6 here. And if you check, 2x times x is 2x squared. 2x times 6 is 12x. 3 times x is 3x. And 3 times 6 is 18. So here are our factors. 2x plus 3 and x plus 6. And here's how we'll do it over here. Find the GCF of the first two terms, and you can group them this way. It's called grouping, which is going to be a 2x, and what's left is x plus 6. And then we take out the GCF of this. We should have the same factor left in our parentheses, so we'll check. It's going to be a positive 3, and then we have x plus 6. Notice we do have matching binomials here. So we've got 2x plus 3, and we can do this because of the commutative property. Because notice you're multiplying the 2x times this x plus 6 factor and the 3 times the x plus 6, but if you write it like this, you're still multiplying both those terms by both of these terms. So that's why you can swap the order. Either way, you get the same factored form, which should give you the same zeros as well. So x is going to equal negative 3/2 for this factor and equals negative 6 for this factor. Number 11. So a equals 1, so we're still just finding factors of 12 that add to 8. And those will be 6 and 2, so it's just x squared plus 6 times x squared plus 2. Those are our factors. To solve, you're not just going to swap the sign like you do for quadratic trinomials. You'll be taking some square roots here. So if we subtract 6 from both sides, take the square root of both sides. Notice you have the square root of a negative number. So you're going to have an I come out front, and 6 does not simplify as a square root. Very similarly over here, x is going to be equal to plus or minus I square roots of 2. Here are our roots or solutions. Lastly, we have a quartic trinomial where a is greater than 1 and there is no GCF. So we're finding factors of 3 times 6, which is 18, that add to 11, and those numbers are 9 and 2. So let's set up our box and grouping just to remind ourselves of both ways to do this. We've got 3x to the 4th and 6, and notice this is 11x squared, so this is not going to be just a 9x, it'll be a 9x squared and then a 2x squared, because those are the terms replacing your middle term. So if we have the original here, our replacement is that 9x squared and our 2x squared. All right, so GCF of all the rows and the columns, here we have 3x squared. Here we have 2, a positive 2. Here we have x squared, and here we have just a positive 3. Let's check. 3x squared times x squared is 3x to the 4th. 3x squared times 3 is 9x squared. X squared times 2 is 2x squared, and 2 times 3 is 6. So that's good. Let's do it with our grouping method as well. The GCF of both of these terms is 3x squared. Left over is x squared plus 3. The GCF of both of these terms is just a 2. And we've got, and that's a positive 2, an x squared plus 3 as well. So final factored form for both of these is the same, of course, because it is the same problem. So solving these, x squared is equal to negative 2/3. So square rooting both sides, x is equal to plus or minus I square roots of 2/3. And then we've got x squared equals -3, square rooting both sides. X is equal to I squared of 3. By the way, sorry, plus or minus I squared of 3. And here are our 4 roots or solutions. All right, Opties, that is it for factoring polynomials. See you next time.